like research papers on specific diseases, and so like a big medical database like PubMed is what we're using for the data, but there's a lot of different databases for medical and medical research. And the idea is for rare diseases, right? So if the average internal medicine doctor, right, they're familiar with the most common diseases or the most common like cancers, but the really rare ones they might not be so like aware of, right? So the idea is that we can pull information and extract it from the latest research on certain diseases and basically highlight for the doctors or the medical professionals like what's really important from that paper and like the symptoms, the treatment, the management, the diagnosis of the disease. Because some of these papers can be 50 to 100 pages, right? So for them to take the time to read through, and not all of them are accurate or great. So the idea is to extract information quickly. So right now, this project is using static data. So we've pre-selected articles, but here I have two different pipelines, right? So I'm going to search the disease name. I'll select myself. And so we have a few parameters on the side, right? So we have the K values to the 10, the chunk size to 1,000, the overlap to 100. The abstract means that we're just pulling the abstract information from the papers, not the full paper itself. And then we have a vector store and the model. So down here, I can give it a rating. Let's say this is one bad example, right? And then I could use like a model, let's say like GPT-4, and run as well. And so for GPT-4, you're going to see that higher latency is a little bit slower than GPT 3.5, but we can just give this like a... So now it's really like what's interesting, the whole reason of working with Lancsmith is if you're working with these different RAG pipelines and there's all these different parameters within the different RAG pipelines, there's different strategies, and there's just like probably hundreds of different parameters you could eventually play with, right? Like different vector databases or embedding strategies and so on. So what this does is it takes a snapshot of exactly what I just did. So now we can take a look and we can see it, right? So we can see the GPT 4.0 had a latency of 12 seconds compared to the 3.5 of 3.59 seconds, right? So it's almost 4 times slower. And we can see the price, right? We're working with like a tenth of a penny or a little bit more, or 8 cents, right? So we're looking at it, I don't know, almost like 50x in price, right? But was the answer really 50 times better? And the token size, we can see since we ran the same parameters, are equal, or basically the same. And so what's nice here is like you can click on this and you can basically see the run. So if we look at, let me bring it up, the code, right? So in LangChain, they have like what's called like LangChain expression language. So you create a chain, and so what we're seeing here is the chain, right? So like the order of operations and a snapshot of what happened, right? So it's returning exactly the documents. So we can see here actually that a lot of the documents, because we have overlap, it's returning a repeat of documents, right? So what I figured out by testing around is like if we change that to phi, it's like this model, we rerun it, this sometimes breaks on GPT-4, so we'll see what happens. But now I'll let that run. But looking at different vector stores, you might get back different results. But why this is interesting is because you see here, I gave feedback, right? So we can see the feedback, we can give the score, we get the key, we can have the comment, I have the metadata, right? So I have a snapshot of all the parameters. So this way, if it was a really good run and it was a really good answer, I'd be able to see exactly what parameters I had in place, the exact input, the exact output, so I could basically use that information to build my model in the right direction. So that's a really interesting part of like Lancsmith, basically just like taking a snapshot. You also have these monitoring, which is for the most part pretty basic, but you can look back and you can look at feedback, so you can look at over time, what's like your average feedback. You can see, okay, this got a 1 or a 5. So let's see if we click this one or this one. Right, so it'll take us to the actual run, and then we can look and say, okay, what about this run gave us a score of 1, right? Because it's good to look at really good answers and really bad answers. And so another portion of the application, actually, so I'll stop there. So are there any questions on this portion of it?
So that can you just go back to the where you were showing like the documents part that was in. So these are the documents, I guess, that are selected in order
Exactly.
to feed to the RAG pipe. Yeah, to feed to the
Yeah.
LM.
So actually, so now that I ran this right and it loaded, so we can see this first run here was using like the Chroma, and we can see there's a lot of repeat, right? So like the indexing, but now when I use the FIAS data store, we can see that there's not as much overlap, right? So we can just see like the way that it indexes and then it pulls information, it's a little bit different. So just like that quick change of parameters, you can see an improvement. Now, if it necessarily improved the answer or not, I guess you have to look into further, but it's interesting to look at things that quickly. You can see the exact input. And then here, you could actually see exactly what got fed to OpenAI, right? So here's my prompt, here's the context, and then here's the output, right? The answer that we actually saw on the screen. So it's a snapshot of everything. It tells you the price, how much you spent per run, but basically everything's saved.
Mm-hmm.
And so another nice part about this is that you can run evaluations, right? So after you do some testing and you can figure out which pipelines are working the best for you, you can basically what you do is you create a data, and these you can use this. You can strategize this in different ways, right? But let's say you found a really good pipeline that was getting really good answers, and now you want to test how the different models perform. So you can see here I ran the 3.5 turbo, the different 3.5 turbos, the 4 and then 4 turbo. And what's nice here is it evaluates it. So basically what you're doing is you're creating a data set that says this is the input and this is the output I expect, and comparing it to what the LLM actually gives you. And so if we click on this, we can see here's the input, here's what I expect the output to be, and then here's what the LLM actually gave me. And you can see here there's different evaluation metrics, right? So this is done dynamically using, you can use different models using ChatGPT. But here I'm saying, like, is it professional? And that's basically 1 or 0. Is this professional? Is this like of the standard you would expect of a medical professional? Embedding cosine distance is basically how far away is this answer from this answer in the vector database. So the lower the number, the better. So this 0.03 is a pretty good answer. And then just accuracy is just comparing the strings, or like how close are the strings, with 10 being the best. So some of these like evaluations I need to work on because they're kind of right out of the box, and depending on your situation, you probably want to customize things, but it's pretty interesting. And what I think is the most interesting is, so you have all these different tests, right, with different models or different parameters, but you're using the same pipeline. You can then select them and compare them directly, right? So you can see how the different models perform. You can see all the different answers next to each other, the price, latency, the exact answers compared to what you're expecting, with all compared to the entire test data set. So that's this is probably a really powerful tool. We haven't gotten in my internship to use this too much yet, so we're still kind of working on what evaluation metrics are useful for our use case. But just with human feedback, this is a really nice way to see to quickly tell which models are producing the right answer, and also an easy way to compare. Like I showed earlier, the GPT 4.0 compared to 3.5 is almost 50 times more expensive, right? So is this answer really worth spending 50 times more than this answer? And this is like a really easy way to kind of do that sort of evaluation. Yeah, Kyle?
Hey, so was the document section, were those embeddings or chunks, or was that the full document that it's
That's
going
the
through?
chunks.
Chunks,
Those are the chunks. Yes,
so you can visually see how it's breaking up the document and
exactly. Yeah,
any metadata that's been assigned to that chunk.
exactly.
Cool.
Eric, can you show the code for like the data set code and like the labeled data?
Okay, so
But do you have the Python code associated with that?
yeah, so for this, I'll just show it. Let's see. So I can probably I can like share like, a really simple example. But right, so here's like the evaluators, right? So it's really simple. It's just saying, how accurate is this prediction in regards to information presented, right? So it's not like an in-depth evaluation. That for professionalism, I'm just saying is it well written, and then for this is like a built-in embedding distance. So all I'm doing here is like a really simple function. Um, that's basically an OpenAI function call, and I'm just giving it the input, which is the prompt. I'm passing it the key, which in this case is the different prompts, right? So it can iterate the data set with the inputs. And then this is, right, so you give your function, right? So this could be an entire RAG pipeline. You give your data set, that's going to take the inputs. And these are the different evaluation metrics. You can give the test name a prefix so you know kind of which models, and then here any additional metadata. And you can run this, and this will create the evaluations for you.
And then can you show the that data set? Uh, where is it? Where you have like a data set name, and then where does that points to like a data set somewhere, right?
So this dataset name I just created it here. Right, so this is the AHP demo, and you can just come here and do add example, and you can just create your data set right here. You can also push it with Python, but you can just create it in here as well.
And you created like some labeled data, right, in your Python code?
Yeah, let's see. Trying to find where I did it. Right, so here, right? So you can basically, here's an example right, that I was testing around with, but here you can just basically give inputs and outputs if you want to create a really quick sample set, and then you can push it to the Langsmith like this, right? So you're
Right. So let's just scroll up a little bit. I want to show just like so basically like with any kind of ML, can you just show the label data, like the outputs?
right here. Yeah.
Exactly. So with so any kind of ML model doesn't have to be an LLM. Like any like this could have been like 15 years ago. Uh, like basically what we're always doing is like we want to make some sort of prediction. And then the way to evaluate it, like say we want to predict like what the temperature is going to be tomorrow. So we feed a model, like an ML model, like some sort of inputs, like here's the location, here's the day of the year it is, here's what how what the temperature was like yesterday or something like that, and then we're just going to make some sort of prediction. The way that we're going to know whether or not we want to see like how good a job our ML model does. So a way that we can do that is that we can give it this kind of we can give our model like this information like of previous days. So I can say like let's take like a month ago and give it like the location, the day of day of year it was a month ago, and like how what the weather was like 2 weeks prior, and then see how well did my model actually do when we have the answer. Okay, and the closer it does to the actual answer to what it predicted, right, the better. So this is very similar. This is really like the same exact concept right here. Basically, like what Eric's doing is feeding like an input kind of like question, to our LLM. So that's like this agent memory. That's that's the question. The other input, I guess, is the document or like the document text, and then you could see like he's providing the output, right? Like this is the answer. This is what we know to be the truth. All right. So based on that, how well a job does it do? So when you evaluate it, you can then see like how well does the prediction, right, or does the how well does like our LLM pipeline produce the output that we know to be the answer. Okay. Now with an LLM pipeline, like it's going to be text, and it's generating the text. So the text is not going to be like lots of times as simple as yes or no or one or zero or whatever. But so then what he's doing, he's saying, well, what we can compare the embedding. Like we can see like if they say, it's going to be like hot and humid, I can embed that and then see how close that is to like what I typed in the text to be, right? Or for his specific example with like seeing rare diseases and seeing or predicting or like seeing the symptoms of it. Like so we give a rare disease, this is what I expect, how I expect you to describe it, right? The doctor can write in the output, right? This is the rare disease. The output would be like, we expect you to see these bumps and get a fever or whatever. And then we can see what does the LLM produce and embed both the actual answer and what the LLM predicted and compare how distant they are, right? Do a cosine similarity. And the closer they are together, the better. So it's like the way this stuff works is you need kind of a sample answers, right? And then you see how well the LLM does at predicting what we know to be the sample answer, or as Eric has put it to me before, like the ground truth. Like this is the ground truth, and then how well does the LLM do on predicting the ground truth? And the idea is if it does a good job at predicting the examples I give, then we think that it will do a good job in predicting things that we don't even get, when we put in the wild and people put in any old thing. Now, that's not always true. Like, that's not always the case. You kind of have to take different measures to ensure that. But that's the idea is like, if we can predict, weather from a month ago, we should be able to predict, given these inputs, we should be able to accurately predict weather in the future, given those same inputs. That's the idea. I don't know. We can talk about that more, but that's kind of the idea of how you evaluate machine learning models. Any questions about that or anything to follow up on?
That's what I was trying to say. Everything he said.
We can say it again. We can go through it. It's a smart concept to do. Like I'm glad other people have thought about it. There's a lot to it, but we can, like I said, originally this was a data science course, so we can talk more about that, in future classes. Yeah, Robbie.
Yeah, Eric and I had talked a little bit a week or so ago as he was starting to dive into Langsmith. And Eric, if you wouldn't mind just sharing a little bit of kind of the intuition you shared with me about like the potential Langsmith has in kind of not just like an evaluation context, but also just like a general ML ops tooling context. And for reference, it's a relatively new tool, and so it doesn't have a ton of documentation or educational materials that have kind of been put out about it. And I also just like if you could share, as you've now been working in it, doing kind of a deep dive, like any big takeaways that someone might not find if they want to play around in Stack Overflow that you just kind of found in your experience.
Yeah. Well, I think like right now, what's useful for the internship I'm working on is right there's in a company there's gonna be a lot of people with a lot of different skills, right? So I'm working on medical information that I have like no domain knowledge on except for the data that I'm playing with normally, like just to test things. So what's really nice is, so one thing I was going to get to is right. So on these runs, right, you saw I gave some feedback on some. So like a really simple feature but nice is that when they get good scores, they automatically get added to a data set. Right, so we know these are our best answers, which, like, if you want to use for fine-tuning in the future, could be useful. But then somebody with not as much technical knowledge can easily come in here, click on this, right, and they can edit. And let's see, they can. I think there's ways that they can add feedback. Or even just so if they wanted to, let's say we want to use these best answers to create our fine-tuning model, they can come in here and change the one or two things the model got wrong. So then on the next iteration, we can use these really good answers, make them amazing, fine-tune the model, and come back. But I really just think it's a really nice like interface between like on the technical side and the team that needs to come and actually say like, okay, these answers are good and these answers are bad to help us build our data set. Like that's the biggest use case I'm seeing right now. The evaluation metrics I think are really interesting, but I just don't know if they're really comparable to like the human eye right now. Like they're just like at the end of the day, it's still going to take someone from my team to come in here and read the answers and say, okay, this one's good. And then what's also interesting is like when they come in here and say, okay, this answer is really good, I can look at the trace, I can look at the metadata and say, okay, these are the exact parameters that give us the best answer.
Yeah, it's kind of cool. It's like a way to think of like, all right, how do I debug? Like an LLM pipeline. Like say like
Mm-hmm.
this LLM pipeline is too slow. Well, then you can kind of see on the left, like we can see where do we really slow down, and it looks like it's in this chat open AI call.
Mm-hmm.
So maybe
Yeah.
like there's a way to optimize that, right? Or we would know at least at the very least, like, hey, we don't have to spend our time on these other components of the pipeline. We just have to look into this. But another part in like debugging would be like, especially with Eric's project, where it's like medical trying to be used by medical professionals, is like accuracy. So like, what are the components that are leading to very inaccurate results? What are the components that are leading to more accurate results? Right, like one hypothesis it seemed that Eric had was like, or maybe the team had was, hey, if we're using more PDFs, like more research papers as opposed to fewer of them, then we'll get like more accurate results, right? You could also imagine more recent ones or higher quality, but you don't know. Like I don't, we don't, you don't actually know the answer to that until you see the end result and then kind of like have some doctor or some reliable source telling you this is good and this is bad, and then you can start to try to figure out why. So getting this like X-ray or like this view into what went on in each run is really useful. So that's kind of one component. Like this is kind of like a debugging tool, especially like in the like pre-production stage. The other thing, can you just click on like the overview, like where you also see the tabs of like uh, the monitoring and things like that? I forget where that is.
Here.
Yeah, so you can see that. So it's like you see there's the runs, the threads, and the monitor, and like the monitoring, right, can also be used for just like after it's been in production. Uh, so you can see how many calls to the LLM, like how expensive this is, how long this is taking in production. When you get like real users. The other thing that's kind of cool that you can see is like, remember, it's tracking the inputs and outputs, so you can see in production if you can track the inputs, like what are the questions that users are actually asking to the pipeline. So you can optimize for that, right? And you can look to see like, crap, we really messed up on this one, or like the output was really bad. So you can, kind of get some user feedback to just see like, how are people actually using this thing, and then how is my LLM, my pipeline actually performing, in production. So it's, I mean, those features are really nice.
Yeah, and that's actually a big use case like that they advertise. So I'm just using it for like basically like a language model, so like an input and output. But they have all this monitoring also built for chat, right? So like just to see like what people are talking about, like exactly like what topic. Robbie, so you have to go to the trace, but here you can annotate it, right? So someone can come here and they can look at a really good answer, add their notes here. You have different like so they can do their own metrics or your own evaluation, and you can set them up. So I was just playing around with these, but you can say like true or false or whatever you want to add. Um, and that could all be done right here. One more thing that I thought was interesting too is so if I go to like my other RAG pipeline, this is a batch. So the first version is just one prompt that's getting all the answer. This is basically 5 prompts going really quickly for each specific question. So the idea here is that when we're just when it's returning all the information based on one prompt, it's only returning those 10 documents for that one prompt. This is going to respond with 10 documents for each specific question, which is supposed to be more accurate. So if they Okay, So you can see here, right, pretty high latency. You can see it came through as 5 different prompts. But what's nice here is if you set a thread ID on it, you can come here to threads and click on it so it combines all those 5 traces together. So this is like a strategy that probably we'll end up using, and so it's really nice. I already thought about this and I combined it all. So now I can see like for that one run of the application, each individual question, and like the idea here is like what happens if like 3 out of 5 questions are performing really well, but 2 of them aren't, right? So you can come in here and like dive even deeper, because what this batch does is it allows you to basically have like an individual pipeline for each model, like for each question that runs parallel. And the downside is cost, right? So this is probably going to be, let's see, maybe for threads, might not have it there. Right. So instead of just like 1, so we're I don't know, like 30 something cents for that, which is a bit more expensive because we're using GPT-4. And you can imagine if you're doing hundreds of these a day, it can be expensive really quickly, but it's an interesting feature.
Yeah, one thing to point out is like this. I mean, so this tool, this is Langsmith, and there's a lot. Like Eric's been showing me kind of like some different resources on it. The YouTube page for LangChain, it has some good videos on it. It has like a couple good playlists. They're not like hours long typically. They're like 2 minutes each or something like that. So you can really move through kind of like the whole playlist in like 25 minutes or 30 minutes or something. And then the other thing to point out is there are alternatives, right, to Langsmith. Like this is kind of like an ML ops, like so tracking these different parameters of your RAG pipeline. But other ones that are good are like MLflow, right? Another team is using MLflow. Langsmith plugs in directly to LangChain. But it can, to some degree, maybe to a large degree, it's just like a little bit of work, work with other RAG pipelines. But also, I put in Slack this other tool called GraphSignal, which will work with Llama Index. So if you're using Llama Index and want to hook something like this up where you can like diagnose what's going on in each component of your RAG pipeline, that's a good tool. Langsmith probably works fine as well. It's just I think we have to do a little bit more research on it to see exactly how to set it up. And this is also a fairly new tool. Like it came out, I forget when it came out, like a month ago or something like that, but or maybe it was popularized like within the past month. So I'm sure they'll be adding more features to it too. Cool. Any other questions about this? These are really nice tools, really nice tools to explore. We like I said, I think like we see it come up a lot. So especially if you're like, if in the future you find yourself like in an interview that's asking about LLMs, like just exploring these tools, trying to work with them in a project, really useful because it just gives you a lot of insights into like how you can optimize LLM pipelines. Cool. All right, I can start.
Just to repeat what you said, the YouTube channel is where I learned everything for this. But just one correction, it's not like a half hour. I was probably watched days worth of YouTube videos, so it's a lot of content.
He's lying. He's lying. It's half an hour, guys.
Yeah.
All right.